Hello guys, welcome on Tesla Adventures. Today in this video, we'll be discussing the chasing problems, which are a special type of chasing problems, which are also called as cat-mouse problems. So in this type of problem, you can see that there is three objects A, B and C, which are situated at the three vertex of the triangle, equilateral triangle, and they are moving in such a way such that their speed is constant throughout, their speed is v, and they are always chasing the neighbor, which means that this is always moving towards this one, this is always moving towards this one, and this is always moving towards this one. So you can see that the motion of their cumulative motion would be like this, that at this point, let's suppose this particle is moving towards this one, and at this point it is moving towards this one, and at this point it is moving towards this one. So they are always moving towards the neighbor, and their speed is constant throughout. So you can see that they will definitely meet at the centroid or of the figure. In this case, the triangle is this is the equilateral triangle, so they will meet at the centroid of the equilateral triangle. And if you can see the scenario that if we connect them with a line at any instant of time, then they will form a triangle. Okay, so at any instant of time they will form a triangle, and we can connect them with a line. So the speed of the this particle is v, and the speed of this particle is v, and speed of this particle is v. Now speed is constant, so we have to find out the time in which they all will meet. So I am discussing two methods for solving this kind of problem. You can see that in method 1 we can say that they are always moving on this triangle. You can see that they are always moving on a equilateral triangle, and the side of the triangle is reducing till 0. So I can say, and I can also say that the centroid of each triangle is same. There is a common centroid which is same for each triangle. So if I say that any of the particle, let's suppose this particle is moving at an angle of, this angle is 30 degree with this median. So at this time also you can see that if I draw the median, this will be the median, and this angle will be 30 degree. So at any time each of the particle will have a same component of velocity along the median. So this is the component of velocity along the median, which is v cos 30, and by moving with this velocity they will reach to the centroid. So we have to find out the time in which they will reach the centroid. So we have already discussed that they will be always moving with the velocity of v cos theta along this median. So the length of this median, initial length, was a by root 3, and finally this length becomes 0. Okay, so the time taken by the particle to move on this triangle from this corner to centroid is distance, which is a by root 3, and velocity is v cos 30. So time taken is a by root 3, and velocity is root 3 v by 2. So it is 2 a by 3v. So the time taken by the particle is 2 a by 3v. This is the time. Now let us find out the same time by another logic, which is the logic of approach velocity. We can say that the initial approach velocity is, this is v by 2, v cos 60 is v by 2. So v approach is equal to 3v by 2. Okay, so this is the approach velocity, and the time taken by the particle. See, you can see that these two particles are initially separated by a distance of a. Okay, So they are initially separated by a distance of a, and finally, and obviously you can see that at any point of time their approach velocity will be same. This is v and this is v by 2. So at any point of time their approach velocity will be 3v by 2. And by this approach velocity their relative separation is decreasing from a to 0. So approach velocity is 3v by 2. So the time taken would be a, distance traveled relatively, upon approach velocity. So this is 2a by 3v. So this is the time taken by these particles to meet. And obviously we can imagine the situation that in the time when any one of the particle will reach the centroid will be the same time at which rest of the two particles will also reach the centroid. And also it is important to note that if you have to find out the distance traveled, so distance traveled will be speed into time taken. Time taken is 2a by 3v. So the distance that is traveled by each of the particle is 2a by 3. Okay, in the complete motion. This distance you can see. Okay, now let us discuss another kind of problem. Let us see that in the similar type of problem there is a square in which all of the particles initially are at corners of the square and they are moving in such a way such that their speed is constant and they are facing always towards each other. So this is facing towards this is facing towards this. Now let us see that again we can see that they will meet at the centroid of the square, which is the center of the square, and therefore at any instant of time they will be making a square which is of some lower side length. So I can say that this is if initially this was the diagonal, semi-diagonal, then finally this would be the semi-diagonal, and you can see that the component of velocity along this diagonal will be v cos 45. And it would always remain v cos 45 because in this situation also you can see that this diagonal and this velocity is making an angle of 45 degree. So I can say that with v cos 45 velocity it has to move a distance of semi-diagonal. So semi-diagonal is a by root 2 and upon time. So time taken would be a by v. Okay, now you can also use the second approach in this problem. You can see that in the second approach, v approach is equal to v, and the component of velocity of this velocity along this line is 0. So v approach is v. So the time taken would be relative distance, which is a, upon v approach. V approach is v. So the time taken is a by v, which is the same result which we have obtained from the method 1. Now in this question they are moving on a hexagon. So now again we can solve this question by using method 1, in which we were finding out the velocity component along the semi-diagonal. So this angle is 60, we all know that, and this component would be v by 2, and we all know that each of the semi-diagonal is of length a. So the time taken by this particle to reach the centroid would be semi-diagonal a upon velocity v by 2. So the time taken is 2a by v. And if I find out it with the second approach, you can see that this angle is 60 degree and velocity component is v cos 60, which is v by 2. So v approach is equal to v minus v by 2. So it would be v by 2, and the time taken would be equal to a upon v by 2. This is the time taken by the particle to by all the particles to meet. Now there is another kind of tough problem which I would consider as tough problem. In this problem you can see that there is a mouse which is moving with a constant velocity of u along the x-axis, and there is a cat which is initially at a distance of d perpendicularly to the mouse. This is the d distance, and this cat is moving in such a way such that the speed of the cat is constant, but cat is always facing towards the mouse, which means that if, let's suppose that cat is at this point, then the mouse would be at this point, because cat is always chasing the mouse. So mouse is at this point and mouse is moving with a constant velocity of u, and cat is at this point. So we have to find out the time in which cat will chase down the mouse. So let us see that if the speed of the cat is constant, then this is v, and this is u, which is the velocity of mouse. This angle is theta, let's suppose. So the approach velocity, v approach, will be equal to v minus v cos theta. And by this approach velocity, let's suppose that the relative distance between these two is x at this time. So let's suppose that v approach is equal to obviously dx by dt with a negative sign, because x is decreasing because they are approaching each other. So minus of dx by dt is equal to v minus v cos theta. In fact, v minus u cos theta. This is u cos theta. Okay, this is a Pathfinder problem, and after this video I'll be bringing you such kind of problems which are exclusively found in Pathfinder only. So minus dx will be equal to v minus u cos theta into dt, and integrating this expression, the limit of d would be from dx would be from d to 0, and limit of this would be from 0 to t, where I have considered that t is the time in which they will meet. So using that negative sign, let us change the limit, and d is equal to, this is integration of 0 to t v dt minus integration u cos theta into dt. Limit would be from 0 to t. Okay, now d is equal to vt minus u is common, and this is the integration of cos theta dt. The limit would be from 0 to t. Now you can see that this theta is variable. Obviously this is variable, and initially this theta was 90 and finally it would be 0. So we cannot make an expression of theta, and we cannot find out the variation of theta with time. So what should we do with this term? So let us see that the initial separation between cat and mouse in x-axis was 0. Obviously they both were on y-axis and their initial coordinate, x coordinate, was 0. So I can say that x initial of cat and x final of mouse is same, which is 0. In fact, x initial of mouse. Now we can say that when the mouse will chase down the cat, in fact the cat will chase down the mouse, then their final x coordinate will also be same. So x final of mouse and x final of cat would be same. So delta x of cat, which is the displacement traveled by the cat in x direction, and delta x of mouse, which is the displacement traveled by the mouse in x direction, is same. So we can say that their x displacements are same. So the displacement traveled by the mouse, x delta x mouse, will be velocity of mouse into time taken t, and the delta x of cat will be equal to the velocity of cat, which is v cos theta in x-axis. At any instant of time this velocity will be v cos theta. So v cos theta into dt, integrating from 0 to t. So delta x of cat will be equal to v integration 0 to t and cos theta. So if we equate these two, then u t is equal to v integration 0 to t cos theta dt. So you can see that the value of this term, integration 0 to t cos theta dt, is ut by v. We can substitute this value here. So d would be equal to let us see that d would be equal to this was Vt minus u, Vt minus u, and this term is ut by v. So this is u t by v. So d is equal to v square minus u square into t by v. So the time taken by the cat to chase down the mouse is dv by v square minus u square. So this is the time taken by the cat to chase down the mouse. We know that the cat is moving with a constant velocity, so the distance traveled by the cat, would be the speed of cat into time, which is equal to v square d by v square minus u square, and the distance traveled by the mouse will be the velocity of mouse into time t. So it would be dvu upon v square minus u square. So this is the cat mouse problem, which is considered to be a tough problem, and I'll be bringing more such problems from Pathfinder in the next video. I hope now this problem is easier one for you, and keep practicing and keep motivated. Thank you.